Systems engineering or a systems approach often confuses people. They feel that it's very much a technical discipline. Think of systems engineering as an organisational framework for making decisions. The first part here, defining and analysing requirements before design and build. Requirements very much geared to the outcome in which the organisation is seeking. Ensuring that different subsystems work together. Interoperability. If you take a car, it's got a brake system, a steering system, an entertainment system. It all works together. Interoperability. Using verification and validation to confirm assets meet operational needs. So again, comes back to standards like ISO 15288, which actually make this simplified. Applying a structured process for the full life cycle, from concept to handover, or from initial demand through to the delivery of value of something. And another key aspect of a systems approach or systems engineering is embedding risk management, assurance, and accurate information throughout. The other secret to systems engineering is always seeing if you can defer the final recommendation up until the point before it'll negatively impact the next decision along the chain of the life cycle. Employees, staff, stakeholders see systems engineering or consider it as being overly complex and just don't understand it. It's one of the simplest things that you can adopt in decision making. And to that point, a systems approach and asset management lifecycle approach are one of the same. So the risk here is because they don't understand a systems approach leads to confusion, which can lead to sometimes embarrassment, anger, confusion, tension between business functions. So if we can provide some basic awareness training, use simple visuals to explain what systems thinking is, you'll find that people will jump on board and realize, wow, this is all around me. If you are actually looking at purchasing a car and making a decision onto what does the car need to have for me and my growing family, for instance, taking a systems approach. So again, complexity and understanding can be reduced or eliminated through some basic awareness training without it becoming patronizing on those undertaking that training. Because a systems approach, systems engineering, systems as a whole looks at the life cycle from beginning to end, it's actually easy to invite that cross-disciplinary collaboration. Simply put, if you're up the front of the process of decision making, inviting all the various functions of the business and saying, well, what is your requirement? You might not have one, you might just need to be aware, or there is something you actually need to set your function up for success. So by facilitating integrated project teams, looking at shared objectives, and shared objectives is quite simple if you have a strategic asset management plan, because they are your asset management objectives. People are used to making decisions in their own way, usually in isolation, in silos. But there can be resistance to new processes, especially taking on a systems approach or a systems viewpoint. The risk here is people just will go from beginning to end, make that linear decision, and actually not consider various interfaces to other areas of the business. But that change resistance can actually be converted to a willingness to get involved with a systems approach, because they can actually see that what they need to support their own business functions can be achieved at the same time taking a systems approach. Because a system inside of an organization exists of the physical assets, the non-physical assets working together, which we also call capability. So again, making sure we can demonstrate the benefits of a systems approach, systems engineering, it will reduce rework, safer operations, and give people a seat at the table in terms of what they need by way of outcome. Because systems approach or systems engineering is all about converting demand to value, looking at the requirements down to specification, etc. We need to manage the interfaces back to business functions, physical assets, and of course, the various services and products that the organization has providing to stakeholders. The risk here is a lack of clarity on who manages the different subsystem boundaries that can lead to error. due to gaps in understanding or even overlapping, which creates ambiguity around that accountability and responsibility. But if we can clearly define those roles and responsibility for the interfaces, test them effectively, early, and really make sure that the organization understands those interfaces, you can move from just interfacing to a function or an asset to integrating the entire life cycle in support of organizational objectives. When first embarking on a systems approach, systems engineering, there is a real risk that people will lack an understanding of what it's all about, the knowledge, awareness, and maybe the ability to do it. But when people start to understand that requirements management leads into specification management and configuration and verification and validation, all sound like big words, but they're all complementary. We'll find that people are somewhat already capable in a systems approach. They're just not yet confident in applying it. So we could apply some targeted upskilling, mentoring, even storytelling, use cases, and demonstrate how a systems approach is all around us. And it really does bring us back to that coordinated activity of the organization. So capability and skill gaps in systems engineering, I think, is less than what people count it to be, having gone through this process before with different organizations. Systems engineering, a systems approach, ultimately supports an assurance outcome, i.e., confidence in the outcome. So moving that shift in thinking, we've got to talk about it in terms of outcomes and assurance as opposed to control and restriction. The risk here is those assurance activities, testing, validation, verification, or progressive assurance across lifecycle decision making is seen as a burden. It's not. It should be seen as effectiveness in terms of controls. So we can get around that or navigate that through reinforcing that assurance prevents costly failures, builds stakeholder trust, is likely to reduce risk, but also provide the opportunity to demonstrate performance in assets, service delivery, and even organizational maturity. So from an ISO 55001 perspective, linking back to, of course, systems engineering, 6.2, asset management objectives and planning to achieve them is a big one. You might also extend that out to risk and opportunity management as well. 8.2, control of change. Of course, that systems engineering or a systems approach really facilitates that process well. Now, looking outside of 55001, you might look at ISO 15288, which is the international standard for systems engineering. You might also look at the INCOSE, INCOSE handbook, which actually helps you apply systems engineering in a real-world environment. So in summary, systems engineering ensures assets and their components are designed and delivered to work together reliably and sustainably over their whole life. And as I said before, think of systems engineering as translating demand through to value, but through a methodical process. The backbone of lifecycle management is very much the same or sits complementary to a systems engineering approach.